Hello everyone. Welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something.
Now welcome back to our machine learning class. In this class we are going to learn about Python libraries. Today's content is mainly divided into several parts: basic syntax of Python, data analysis, data visualization, and introduction to the commonly used Sklearn packages for machine learning. Sequence data structure are used to store and manipulate ordered collection of items in Python. The three most common sequence data structure in Python are lists, tuples, and strings. Additionally, there are other data types like dictionaries and collections, but they are not considered sequential data structure because they are unordered and do not support accessing data elements through a location index. Now look at the code examples. Let's first look at the first line. This line of code creates a list called list1 that contains 4 elements: the string watermelon, the string apple, the float 5.2, and the integers 8. These are mutable, meaning their elements can be modified after creation. The second line of code creates a tuple called tuple1 with 4 elements: the string watermelon, the string apple, the float 5.2, and the integer 8. Tuple are similar to lists, but are immutable, which means the elements cannot be modified once defined. The third line creates a dictionary called dictionary1 with 3 key values pairs: name as the key with the value 10, age as the key with the value 39, and sex as the key with the value true. Dictionaries are unordered collections that store data in key value pairs, allow you to access values by their corresponding keys. The fourth line creates a set called P with 3 elements: the float 2.5, the string 10, and the tuple 1 to 3. Sets are unordered collections of unique elements, meaning they don't allow duplicate values. These examples demonstrate the different ways to create and initialize different sequence data structures in Python, including lists, tuples, dictionaries, and sets. Now, let's discuss a comparison of several Python sequence data structures mentioned above. Lists are kind of data structures that are ordered, meaning the elements are stored in specific order. They are indexable, allowing you to access elements by their positions in the list. Lists support adding, deleting, and modifying elements. You can add new elements, remove existing ones, and change the value of the elements. Tuples are also added, preserving the order of the elements. Like lists, tuples are indexable, enabling you to access the elements using their positions. Tuples allows adding and deleting elements, but unlike lists, the elements cannot be modified once defined. They are considered immutable. Dictionaries are unordered, meaning the elements are not stored in specific order. They are not indexed like lists or tuples. Instead, each element in the dictionary is a key value pair. Dictionaries provide a way to associate values with keys. You can access the values of specific keys, but not the elements based on their presentations. Sets are also unordered, lacking a specific order for elements. It is similar to dictionaries. Sets are not indexable. Sets are used to store collections of unique elements. They do not allow duplicate values, so each element appears only once in a set. In summary, lists and tuples are ordered and indexable, with the main difference being that tuples are immutable. Dictionaries are unordered and store key value pairs, while sets are also unordered and store unique elements without duplicates. In this section, we'll discuss and provide codes that demonstrate how to traverse a list in Python and explain the functions used. This code demonstrates how to traverse or interact through a list named R and print each element along with its corresponding index. Well, let's move on. You may wonder how to create sets. We've provided you with the code examples listed above, which illustrate the creations of different locations using the sets in Python. The code demonstrates the creations of collections using set in Python. It showcases how to create sets with different elements, including integers, mixed types, and by converting a list to a set. It also highlights the difference between creating an empty set using set function and creating an empty dictionary. Now, let's look at the features of set. The code demonstrates the some key features of set in Python. Sets are unordered collections of unique elements, meaning they do not maintain the original order of elements. They automatically remove duplicates. Sets support membership testing with the in operator, allowing you to check if an element is present. However, sets do not support indexing, so you cannot access elements by their position in the set. You can stop here and check the code in your Jupyter notebook. Now let's move on to create functions and classes. Let's look at how to create functions. Here we show you the code, which demonstrates the use of functions in Python. The function is defined to paint a pyramid-like structures with specific shape symbol. The function is called with the argument 6 and $symbol to create a pyramid of height 6 using the symbol $. Lambda expression actually defined an autonomous function, which can contain only one expression, and the expression evaluates to the return value of the function. But other functions can be called in the expression. Here let's take an example. Look, we use lambda expression to perform addition on 3 numbers. All the keywords and variables can be condensed into a single sentence. In lambda expression, the part before the colon corresponds to the parameter of the function, and the part after the colon corresponds to the return statement of the function. Next, let's take a look at the class definition and the initialization in Python. The given code defines a class named JZT in Python. The class has 2 members, variables shape and row, initialized with the default values. The class also has a method called draw, which takes 2 parameters, row and shape. Inside the method, it uses the neatest loop to print a pattern based on the provided number of rows and shape. After defining the class, an instance of the class is created using the statement p equals JZT function. Then, a new value is assigned to the variable shape and row. Finally, the draw method of the class is called using the instance p, along with the update values for shape and row. The pattern is printed based on the provided parameters. Additionally, the properties of class shape and row are printed using the statement print p.shape and p.row. This displays the values assigned to these properties in class instance.